In this exercise, we're going to focus here first on the print, looking for what's missing. What's missing, here's my 0, 0 at this point. What's missing is where this 1.5" radius intersects this horizontal line. We know the horizontal line, here's your y0 with 2 inches between it, so this line lays at -1 inch in y, but we don't know where the horizontal line and the arc intersect. Never mind this connective radius here in between. What we're looking for is the theoretical intersection point of this radius, the 1.5", to this horizontal line at -1 inch in y. The second thing we need to know is where this line and this arc, this 1 inch 875 radius, are tangent. It's not given, and we need to know it before we can program this part. So we'll move off the print for now and come over into our math helps. In math help, we're going to solve for a line arc intersection first. That will be where this arc and this line intersect. If we look at type 13, it says find the intersection of a line and an arc when 2 points are known on the line. Well, do we know 2 points on the line? First of all, the line is straight, so it's at y of -1. So any 2 points on this line, we can give it, and we will establish it. The second thing it needs to know is the arc center and radius. Well, the arc center is at 0, 0 here, and the radius is 1.5. So this type 13 is the one we choose for this solve. Now, never mind what the picture looks like, as the picture probably isn't going to look like what you're trying to solve for. What you want to do is look at your x1, y1 here, and then look at the picture. x1, y1 is a point on the line. Look at x2, y2, so let's give it a point on this line, any point at all. In x, let's say it's at 0, and at y, let's say, well, at y it's definitely at -1 inch, right? So I've got a point here, theoretically, at 0 and -1 inch. x2, y2, look at your picture. That's another point on the same line. So we know that's -2 inches 418, minus 2.418, and y is at -1 inch. Right? That's that point right there. So now we've established a straight line. We're going from 0 and -1 to 2 inches 418 and -1. The next thing it's asking us for over here is the x3, y3. Again, look at the picture. We can see that's the center of the radius. The center of that radius is at 0, 0. So let's tell it it's at 0, 0. And then it's asking us for the radius, which is 1.5 inches. 1.5. And here's our solution, is x of -1.118 and y of -1. So I just wrote those down. The next thing we have to solve for is where this line becomes tangent to the arc. That's line arc tangency, C. Type 17, find the intersection of a line tangent to an arc when 1 point is known on the line. Well, let's look, and do we have a point on this line? Yes, we do. This point is at x of -2 inches 418 and y of -1. So I know that that's a point on this line. The next thing it asks us for is the arc center and radius. If we look over here, the x center of this radius is at -7 inches and 0. So I have that. Type 17 will allow me to put in the information that I know. Again, it's asking here for x1, y1. If we look at our picture, that would be the point on the line. In other words, this point right here. So that x would be at -2 inches 418, and the y would be at -1. x2, y2, look at our picture, that's the center of the radius, which is at -7 in x and 0 in y. And the radius itself is 1 inch 875. Look at over here now. Now our picture looks like our print. And this is our solution. So it's -6.6341 and -1.8389. So I just wrote those two numbers down, and now I'm ready to do my program. Press your mode key and select program, go to begin. So what we're going to do is we're going to start right here and go around the part this way. So we're going to start off with an arc. The x begin is at 1.5 and 0. The x end is at -1.118, which is what we solved for earlier using Math Help 13, and y is at -1. The center is at x, y, 0. There is a Conrad at the end of 3/8. The direction is clockwise, number 1. The tool offset going this way would be to the left of the line. So let's tell it number 2, which is left. Feed rate, tool number, tool diameter, and then continue yes or no. What this means is there more stuff to do, or are you done? Yes, there's more stuff to do, so that would be number 1. And if we have a look, press our look key, we can see the arc now. Now we're going to do a continue mill. The x end is at -2.418, and y ends at -1, because it's a straight line. There's no Conrad at the end, and we want to continue yes. And now if we have a look, we can see our 3/8 radius has been put into between this arc and this line. So we swung this arc to the theoretical intersection of the big radius and this horizontal line, and we told it that we had a Conrad. Now we have another continue mill move. The x endpoints we've already solved for with our line arc tangency, and x is -6.341. I'm sorry, I made a mistake there. -6.6341. And the y endpoint is -1.8389. And there's no Conrad at the end of this line and here. And then we want to continue. Press look to look. Now we'll program this 1 inch 875 radius. So continue arc. The x endpoint is at -6.6341, and the y would be at +1. I'm sorry, the y would be at plus 1.8389, which would be the tangency point. Because the part's symmetrical, the tangency point here and the tangency point up here are identical. The arc center on this is at -7 inches in x, and y 0, there's no Conrad, it's a clockwise arc, and we want to continue. Just press the look key. Here we have a continue mill. The x endpoint is at -2.4418, and the y would be at +1. There's no Conrad, and continue. Press look. We have another continue mill move here. The x endpoint is at the intersection of the line and the arc, which we already solved for, which is -1.118, and y of 1. Continue yes. I'm just going to go back here because I forgot something on this. I forgot to put that 3/8 Conrad in here. So here we are here, and we want to do this last little section of arc to close off our contour. So continue arc. The X endpoint's at right out here, which is at 1.5 and 0, and the center's at 0. The direction is clockwise, and now we're done, so we'll say continue no. And press look, and there's our part.